By the end of this video, you will be able to explain the relationships between viscosity and gas content, eruption style, and volcano type, and you will be able to explain how the milkshake and pastas are analogs to the different lava compositions and viscosities. All right, so we're continuing to talk about the lava viscosities and the differences between felsic lava or magma and mafic lava or magma. And for another simulation, Erica is going to help me demonstrate one of the differences between felsic and mafic, except instead of peanut butter and ketchup and molasses and all things out of the pantry, oh wait, we have stuff out of our refrigerator or pantry. And we're going to do something that we probably have all done at the dinner table and may have gotten in trouble for. But I know Erica would never do this, never, right? Never. So I have a cup of milk, and I'm just going to ask Erica to blow into the straw and make some bubbles. All right, and without making too much of a mess. And how much effort did you put into blowing into the straw and making bubbles?
Basically none. Basically
none. So basically her breath, her carbon dioxide comes right out through the straw into the milk, and that gas comes up and those bubbles come up, and the bubbles came up pretty easily.
Yeah, they came up pretty fast.
Yeah, and pretty fast too. And we can make a real mess really fast. This is probably why kids get in trouble when they do that. So we're going to repeat this, except now, instead of just plain milk, I made a little milkshake with some ice cream and milk. And Erica is going to do the same thing. Same kind of straw, same cup, milk and ice cream, nice milkshake, and we want to see what happens to bubbles. Keep going. Hey.
It's not making bubbles, but.
That's all right. Oh, here we go. We got it on the hair.
Yep.
And we're making a nice mess. Yep, it's all over her hair. And it.
Oh.
Okay. I think we got the point. I think we got the point.
We're good.
Yeah, I think we're good. So, the milk and the milkshake. All right, so it was pretty easy.
Yeah.
It was pretty easy to make bubbles with the milk, but the milkshake took a little...
Yeah, a lot of effort.
Yeah, a lot of effort to get some bubbles. And in terms of not just the ease, but in terms of how they came out, it wasn't nice and gentle. Yeah, much more dramatic. We had a little bit of an explosion. I mean, it ended up on it's still on your face. It ended up in my eye a little bit. I felt some spray on the table, on her nice sweater, and her face, her hair, whatever. But, you know, the risks you take. But at least it was a milkshake and not real felsic magma or lava that was erupting. So the viscosity of felsic lava or felsic magma really prevents the gas from escaping. That's why it took a lot more effort for your breath, the gas coming through the straw, to penetrate the thick milkshake. And then when it did, it finally made it to the surface, we had more of an explosive eruption, which kind of went all over, as opposed to the ease, which you said, to create the bubbles in the very non-viscous milk. So milk is like mafic lava, is our analog to our mafic lava, and the milkshake is our analog for felsic lava. So eruptions at volcanoes that are typically producing mafic lavas, and mafic lavas are so low viscosity, so the lava just runs out very easily. They're not very dramatically explosive. The lava runs out and actually makes the volcano much bigger. So these are typical eruptions that we might see in Hawaii, like what's erupting now at Kilauea, or the eruptions that would be in Iceland at a mid-ocean ridge at a divergent plate boundary. So mafic lava, very common there, very more like a fountain coming out, kind of like the bubbles just coming out very easily. But the viscosity of felsic lava, where it's erupting from, so those eruptions are much more dramatic, and those volcanoes tend to grow higher because felsic lava doesn't travel very far. So unlike Kilauea or Mauna Loa or Mauna Kea, those shield volcanoes on Hawaii, which are big and broad, composite volcanoes are made of more felsic materials, and their eruptions tend to be much more dramatic. So if we think of eruptions like what happened at Mount St. Helens in 1980 or Mount Pinatubo in the Philippines in 1991, those eruptions were much more dramatic. So just like when you blew into the milkshake and it ended up in your hair and on your face and even in my eyes, but I'm not bitter. Those eruptions are much greater because the viscosity is preventing that gas, all those gases, mainly water vapor, steam, and some carbon dioxide and lots of other things, sulfuric acid and sulfuric dioxide, all those gases preventing it from escaping. And another thing we can use to simulate, I just want to get these on the right side, that's also a good analog. More food, why not? So loose, dry pasta. It's pretty easy, just kind of real separate like that, so real easy. Yeah, the spaces form really easily. So uncooked, dry pasta like this, it's separate like that. So it's kind of analogous to the milk. There's spaces in between there. It comes apart very easily. So the fact that mafic lava or mafic magma doesn't have a lot of silica in it, that's what's keeping the viscosity of mafic lava and mafic magma very low, and why the gas can escape. All these open spaces of the dry pasta is very much like the mafic lava. And the milk really just, your breath just went right through and created those bubbles. So the opposite of uncooked dry pasta would be something anybody serving this should have their head handed to them. But this overcooked cold pasta, which is kind of stuck together, you know, when you forget about cooking, I don't forget about cooking pasta, but people do. And it could end up, all the water boils off and you just leave it there and it kind of gets all stuck together in a big lump like that. This would be like felsic. So I know it's kind of gross, but you want to touch and see how it's kind of all stuck together. That stickiness, that's that high viscosity felsic magma. So it would be really hard for gas to escape through something like this as compared to the loose dry pasta like this. So uncooked spaghetti is the mafic, and the cooked spaghetti, the cold, overcooked spaghetti, is the felsic, because it doesn't let the air, the gases, the volcanic gases, to escape, because the silica is making it very viscous, and it makes it much more of an explosive eruption, like what happened with your milkshake, and how explosive that was. So all that silica keeps the gas really in there and keeps all those minerals tightly bound together. But the milk is very loose and was easy for the gas to escape, just like loose pasta is very open and loose. So pasta, milk and milkshake, peanut butter and ketchup, molasses and water. We have all sorts of comparing and contrasting to see the differences between the viscosities of lava at where the magma or lava is felsic and where the lava or magma is mafic. All right.
When you have finished watching the video, you'll be taking a short questionnaire that will ask you to rate your confidence on a scale from 0 to 10 in performing all of the learning objectives, where 0 is not confident or sure you can do any of the objectives, 5 is fairly confident or sure you can do some of the objectives, and 10 is very confident or sure you can do all of the objectives.